Hi guys, welcome to IBA. So we are going to see about the data structure, and the first data structure that is on our list is array. So let's see. So what is a data structure? As we all know, a data structure is a named location that can be used to store and organize a data. So it's a location where we store and organize a data which has a particular name. Now, the array is a collection of elements stored at contiguous indexed memory location. The idea is to store the multiple items of the same type together. Now, here two important I have underlined the two main point, that is elements and index. Now what is this? Elements means the item which is stored in an array is called as an element, and the index means the location of the element in an array in a numerical index form, which identifies the element is an index. So let's see an array. So this is an array. You can see a memory location. In a contiguous memory location, we have array which contains an element F, A, C, E. These are the character elements which are present. F is present at index 0, A at index 1, C at index 2, and E at index 3. So 4 elements are present starting from index 0 to 3. And there are memory locations, that is for F is 100, for A is 101, for C is 102, and for E is 103. So this is basic structure of an array. Now let's see what are the advantages and disadvantages of an array. So array data structure represents multiple data items of the same type using a single name. And in array, we see that the elements can be accessed randomly by using the index numbers. When an array locates the memory in a contiguous memory location, there is no chance of extra memory being allocated in case of an array. So this avoids this is the plus point of an array. So this avoids the memory overflow or the shortage of the memory of an array. So let's see what are the disadvantage of it. The number of elements to be stored in an array should be known in advance. So we should know how many elements we are storing in an array in an advance. An array is a static structure. Once declared, the size of an array cannot be modified. Okay, so once it is declared at the beginning, it cannot be modified again. So, based on that point, second point in disadvantage, I would like to say the insertion and the deletion are quite difficult in an array of an elements, because they are stored in a consecutive memory locations, and the shifting operation is quite costly to do. So let's see some of the basic operations performed on an array. Traverse means printing all the array elements one by one. Insertion means adding the elements at a given index. Deletion is the delete the element at a given index. Searching the element using the given index by the value. Updates the element at the given index. So these are the basic operation. I will tell you how to implement it. I will tell you how the computation works behind it. So let's code now. Let's start. Our first operation in an array is which traversing. Now in this is I have written this code in an C. So you can write it in C++, Python, everywhere. Okay, so this is the basic code. I have included stdio.h. In the main function, I have initialized an array with the bracket, with a box bracket, and I have equaled it to a curl bracket starting from the elements 12 to 101, or all this 6 elements are present separated by the commas. As I know, n is the number of elements present in an array, so which are 6. I have initialized I is equal to 0 over here. Also, for in a for loop, I have initialized an I is equal to 0, and what I need to print is the original array elements present in an array, right? So I is equal to 0, I is less than n. I have initialized a loop less than l till 6th element, and I am incrementing it. So it will print an array present, it will print an element present in an array, and it will show at what index that element is. So here, after I run this code, over here you can see, look at this, it has the original array elements present are 12, 16, 79, 33, 90, 101. This is from ranging from 0, 1, 2, 3. See this it will print all this. So from 0, 1, 2, 3, 4, 5. So all 12, 16, 79, 33, 90, 101. Now let's see the insertion of an array, in how to insert an element in an array. So same step as we followed in an traversing. Include stdio.h. In the main function, we are writing array, we are initializing an array, writing the elements which are present in an array, and we are taking the item, integer item, which is like over here. I have taken the 50. I want to insert a 50 at the kth index, which is 3. So it will not place at 3, it will get placed after third index. So let's see how it will get placed. N is equal to 6. These are the number of elements present in an array. I've initialized I is equal to 0 and j is equal to n. N means the here n means the number of elements present in an array. I am first printing the original elements which are in the array, same as the traversing, what we did previously. Now what I'm doing over here, this is main important part, which is n is equal to n plus 1. Since I'm adding one element to an array, so since I'm inserting one element to an array, I'm increasing the array size. So what I'm doing, I'm including n is equal to n plus 1, so the array size will become 7. And while j is greater or equal to k, I'll run this loop, while loop, from j plus 1 till I get j plus 1 is equal to j. So that is till I get the jth value, j plus 1 is equal to j, and j is equal to j minus 1. And what I'll get after I'll running this code is that that element will get inserted after the kth element. Let's see, and then I'm going to print this element after insertion, same as after applying the for loop on it. Let's run this code and see. Okay, so the original array elements, it will print first all the original array elements starting from 0, 1, 2, 3, 4, 5. Starting from 0th index, it will print 12, 16, 79, 33, 90, 101, and it will insert, it have inserted over here, check this out, it have inserted the value 50th in third index. Okay, it have inserted the value 50 in the third index. So let's check, it is not at the third position, it has inserted in the third index. Okay, so 12, 16, 79, 50, 33, 90, 101. This is the simple code of insertion in an array. So now let's see the deletion of an element in an array. So similar as what we did in a traversing, include stdio.h. In the main function, we are initializing an array with all these elements, all the 6 elements. And what we are initializing over here is a k is equal to 3. That means we want the third indexed element to be deleted. Okay, so I and j, okay, initialize it. We will first print all the original array elements present in it. Means this all elements will get printed first, all this. And then what we are going is to do is j is equal to k. When j is equal to k, that will be the third index. Then j is less than okay, j is equal to k, and while j is less than n, we will run this loop till array j minus 1 is equal to j. Okay, and j will be j plus 1 till j is equal to j plus 1. And we are removing, since we are deleting one element from an array, so the size of an array will get decreased. So we are over here initializing n is equal to n minus 1, so that we initially we have 6 elements present over here. So after deleting the third indexed element, we will get 5 elements present in an array. So now after this operation, we will print the elements after deletion, and let's see how we will get this. So the original array elements over here are shown as this: 12, 16, 79, 33, 90, 101. And since we are deleting the third element, which is like this present in it, it got deleted from the array. Over here, check this out, this element got deleted. So we are left with 12, 16, 33, 90, 101. This is the simple program of how to delete an element from an array. So now let's see the searching of an element in an array. So same thing as what we did in a traversing. In a main function, we are initializing an array with all these 6 elements, and what we need to do is we need to search. We have to initialize which item we need to search, or which element we need to search in an array. So in this array, we are going to search an element which is 79. So as we know from here, over here it is present at the second index of an array. So let's see if we get an answer from that. And then first we are going to by running a loop, we are going to print the elements present in an array, that is the traversing part. And after that, what we are running one loop, while loop, well, j is less than n, from array of j is equal to item, when it will be equal to an item which is 79, break that statement, j is equal to j plus 1, and print that j plus 1 value. Okay, print that position, at which position we have found. Why we are doing this j plus 1? Because it will get the position of an array at what we have found that out. It will not print the what let's see what the okay. So the original array elements those are 12, 16, 79, 33, 90, 101. And at which position what that we got is the third position. Okay, it is not printing the indexed, or else I would have written over here J. It is printing the position of the element which is in an array, so which is the third position, and it is at index 2. So that's why it is J plus 1 we are printing. So this is then simple searching of an array, searching of an element in an array, simple program. So now let's see the updation in an array. Okay, so what we are going to update the elements present in an array. Same thing what we did in traversing. We initialize an array with all the 6 elements. We are initializing also the index at which we are going to update the value, and the value which are going to put inside that index. Okay, so it is 25, which is the value that I'm going, or the element that I'm going to update is 25, and it will get updated with the third indexed element. So then first we are going to print all the original elements in an array by running a loop, and then when array is equal to k minus 1 is equal to item, which is k minus 1, which is the third position. So 3 minus 1 will be the second indexed position. So second index will be 79. It will this item number 25 will get replaced with a 79. So and then I'm again printing the values after updation. This is the operation, this is the main operation over here. And then let's see, let's compile it and see. Okay, over here the original array that we got 12, 16, 79, 33, 190, 101, and in place of 79 I've replaced it with 25 over here. So this is simple code of how to update element in an array.